Hai kelas, Assalamualaikum and salam sejahtera. Solar system debris. Okay, so this lecture will divide it into two parts. So part one will be slide number 1 until 30 something. Okay, so let's see the content of this chapter. So we learn about the asteroids, comets beyond Neptune, and also the meteorites. Okay, for the introduction, okay, so we have known about the 8 planets in our solar system. Okay, there are still billions of other celestial bodies revolving around the sun. So for this asteroid, comets, Kuiper belt object, meteorites, for example, they are all small and of negligible mass compared to the planets and moons. And these rocky and ice called debris are pristine and unevolved bodies. They hold a record of the formative stages of our planetary system. So let's see the asteroid. So the definition for the asteroid is the relatively small and predominantly rocky object that revolve around the sun. So here, for example, we have this Amor asteroid that revolve around the sun, and also the Apollo asteroid here, the red line and the green line. So literally means the star-like bodies, and refer as the minor planets or the planetoids. Okay, so generally move on somewhat eccentric trajectories. Okay, between the Mars and Jupiter. Okay, so a few asteroids have diameter more than 300 kilometer, and the largest known asteroid, called the Ceres, has a diameter of 940 kilometer and mass here and the distance from the sun. So the total mass of non-asteroids amount to less than the mass of the moon. And this Ceres was the first discovered asteroid by Italian astronomers, this guy, okay, when searching for an additional planet orbiting between Mars and Jupiter. Okay, for the orbital properties of the asteroid, okay, the discovery of Ceres was followed by the 3 other asteroids, which Pallas, Juno, and Vesta. Okay, as 2018, there are known asteroid 700, almost 700,000 asteroid as documented by Minor Planet Center. Most of them found in the asteroid belt. You can see the asteroid belt in the figure in the previous slide. So the asteroids in the asteroid belt are most likely primal rocks that never managed to accumulate into a genuine planet. Okay, continue for the orbital properties. Okay, so there is far too little mass in the asteroid belt to constitute a planet, and the marked chemical differences among individual asteroids indicate that they could not all have originated in a single body. So the gravitational field continuously disturbs the motion of this asteroid, preventing them from aggregating into a larger body, from expanding into a large body. So for the physical properties, most of the asteroids are too small, okay, and therefore indirect methods are used to find their size, shape, and the composition. And these asteroids have very different composition from the other planets and moon. And asteroids are classified by their spectroscopic properties. We have C-type, S-type, and M-type. So the C-type means the carbonaceous, S is silicate, and M is metallic. So for the S-type asteroid dominate the inner asteroid belt, whilst the C-type asteroid increase in number as we move outward. Okay, and then for the C-type, are primitive materials. They have not been subject to significant heating or chemical evolution since their first form 4.6 billion years ago. And what is the stellar occultation? The stellar occultation was used, okay, to estimate, okay, the size of the asteroid from the amount of sunlight and they reflect and they heat they radiate. So it's called the stellar occultation. The largest asteroids are roughly spherical, but the smaller ones can be highly irregular. So there are 99% of asteroids more than 100 km are known and catalogued, and 50% of asteroids is more than 10 km. Okay, for the Vesta, it appears to have undergone volcanism in distant past. Okay. Okay, so we go to the asteroid observation from space. Okay. Here we have the Kepler and Ida. Okay, this one is the probe. The probe Galileo made the first close-up view of the asteroid on this object and this object. So there are irregular shape, okay, as we can see this figure with irregular shape and diameter range about 20 to 60 kilometer, okay. And also they have the craters covered with layers of dust. Okay, both are thought to be fragment of larger object, okay, and either much older than the Caspar. They can easily estimate the age of this object due to the craters and the chemical reaction from the physical properties also. They can estimate the ages of the body. So Ida has a tiny moon called Dactyl. Okay? Therefore, Ida's mass is here and their density can be calculated, classifying it as an S-type asteroid. For the Matilde, is a C-type asteroid visited by the NEAR. NEAR is a Near Earth Asteroid Rendezvous spacecraft. Has a diameter 60 km, mass and density. Okay, its low density and unexpectedly large crater size suggests that it may be loosely bound and has porous interior. Okay, how about Eros? Okay, Eros here has a size this and heavily cratered. We can see it's a heavily cratered here, and a fractured interior. Okay. Okay, now we go to the Vesta. Vesta, this one is photos by Dawn in 2011. The third largest and second most massive asteroid. Okay, mass, diameter, and density here has a differentiated structure with a crust, mantle, and 200 km diameter iron core. Maybe the only genuine and surviving protoplanet during the formative stages of the solar system. And also, this Vesta has a 22-kilometer mountain in the South Polar Basin. Okay, the Earth's crossing asteroid. So, there are the eccentric parameter between 0.05 to 0.3 that almost remain between the orbit of Mars and Jupiter. Okay, so the gravitational field of both a planet can disturb the normal asteroid orbit. So the Earth's crossing asteroid have paths intersecting the Earth's orbit, leading to the possibility of collision with our planet, have highly elliptical orbit or do not lie in the main asteroid belt, and are known as an Apollo asteroid if their orbital semi-major axes are more than 1 AU or Aten asteroid if otherwise. Okay, for the Amur asteroid is the asteroid whose orbit cross only the orbit of Mars. Okay, so this one is finding the finding on 2018. There are 11935 non-Earth crossing asteroid, mostly discovered in 90s. Okay, so also the potentially hazardous object. Okay, they found the object in 150 meter in diameter, and the edge is about 7.5 billion kilometer distance to the Earth. Okay, and also 5179 Tau Tethys, okay, missed the Earth by 1.5 billion kilometer in 2004. So that is all the information about the Earth's crossing the asteroid. Okay, and also this one you can read this Earth crossing asteroid here, and also about the impact of asteroid that can cause a fatal blast wave and possibly accompanying tidal wave, okay, which means the tsunami. About the extinction of entire species, and also the monitoring system by CNEOS and JPL to monitor the possible asteroid impact in the next 100+ years. Now is the orbital resonance. Okay, about the Trojan asteroid which share orbits with larger celestial bodies and mostly in the orbit of Jupiter, locked into 1:1 orbital resonance with its strong gravity. Okay, and the Lagrangian points is 5 places where a small body can orbit the Sun in synchrony with a planet, calculated by French mathematician, this guy. Okay, and 3 of them, L1, L2, L3, lie on the line joining the planet and the Sun. Okay, also about the Lagrangian point, all 5 revolve around the Sun at the same rate as the planet. Okay, so you have L1 until L5 here. So in principle, an asteroid at any of the Lagrangian point will circle the Sun in the same position relative to the planet. Okay, for L1, L2, L3 that lie on the same plane here is known to be unstable because a slight displacement from this point will cause the asteroid to drift slowly away. Therefore, no asteroid orbit near these 3 points of Jupiter's orbit, since they are constantly subjected to small perturbation by other planets, asteroid, and also solar wind. How about the L4 Lagrangian point? Is posited at Jupiter's eastern sky, and rather than the trailing point L5. So the main asteroid belt also has structure due to resonance. Okay? Asteroids whose orbital period are simple fractions of Jupiter's period and absent from the overall distribution. Okay, and this point is important about the Kirkwood gaps. Okay, what is the Kirkwood gaps? Is the resonant gravitational tugs from Jupiter leave gaps in the distribution of asteroid period in the asteroid belt. So this gap called the Kirkwood gap. Okay, now we go to comets. Okay, comets, as you can see in this figure, okay, is like a flash here. It's a fan of fuzzy patches of light on the sky. So travel in highly elliptical orbit with the sun at one focus. Okay, so the brightens and develops an extended tail. Here you can see that its tail, as it nears the sun, becomes faint again while receding. So means hair in the Greek, and shine by reflected sunlight. Okay, we can see the tail of the comet motion here. Here is the sun, so we are here, the Earth. So actually, the comets it's very wide motion. Okay, if you can see from this illustration here. So the comet orbit was just like this. Okay, very wide motion in the outer space. So the comet appearance and structure. Okay, we can see here the coma nucleus in the middle. Okay, to the sun and tail here. So a typical cometary nucleus is only a few kilometers in diameter, and the ice surface of its nucleus here is sublimes and expand into space, forming a diffuse coma or halo here of dust and evaporated gas around it. The comet becomes larger and brighter as the comet nears the sun and reaching 100,000 kilometers in diameter at maximum size. So the hydrogen envelope, okay, is the hydrogen envelope here. You can see in this figure, this layer. It stretches to 1,000,000 kilometers of space when distorted by the solar wind, while the tail spans as long as 1 AU when closest to the sun. From Earth, only the coma and tail of a comet are visible to our naked eye. Most of the light comes from the coma, while most of the mass resides in the nucleus. So there are two types of comet tails. We have iron tails and dust tails. Okay, so what is iron tails? You can see here the different feature of iron and dust tail. So for iron is a straight made up of glowing linear streamers, and spectra show emission lines of ionized carbon monoxide, nitrogen, water. But for dust, it's a broad, diffuse, and gently curved here. Okay, this is the feature for dust tail, rich in microscopic dust particles that reflect sunlight. So comet tails are always directed away from the sun. Okay, so the gravity is causing particles to follow the same curve path as its parent comet. The solar wind causing particles to trail radially outward from the sun. Okay, and the Halley's comet. What is the Halley's? Okay, Halley's comet is here in this figure. It is discovered by the British astronomer. The appearance of this comet in 1682 was not a one-time event, but instead has a period of 76 years. So they found maybe some circle of the event Halley's comet ni. Okay, dia boleh berlaku lah maybe cycle over than 76 years and predicted to reappear in 1758. Okay, but actually they did not see, okay, did not live to see it, and has been observed 30 times since its first historical record in 240 BC and will return in maybe 2061. Okay, this is this illustration for the plan of Halley's comet. Okay, here. Okay, this is the Halley's comet. So maybe the motion is like this, very far away from the sun, and it makes a very wide motion. Okay, from the sun because of the tails. Okay, remember it has two tails, dust and the dust tails and also the iron tails. Okay, so these comets can occasionally be estimated by the comet's interaction, okay, with the other solar system object or by determining size of nucleus. Okay, so they can find out the mass of the comet. And the method yield typically cometary masses is this range comparable to the masses of small asteroid. A comet mass decreases with time since some material evaporates from its surface each time it around the sun. Okay, Halley's Comet and Hale-Bopp Comet may be destroyed after 1,000 orbit around the sun. And this comet made up of dust, okay, and gases which emit spectral lines of hydrogen, nitrogen, carbon, and oxygen. Okay, so what is the comet nucleus? It's like a dirty snowball. It is a mixture of methane, ammonia, carbon dioxide, and water ice. Okay, now we go to the next one, is the space mission to comets. To date, several comets have received close-up visit from human spacecraft. Okay, so there's one called Halley's Comet, visited by Vega 1 and 2, and also from Japan, Sakigake and Suisei and Giotto. So they went within 80,000 kilometers and 600 kilometers of the nucleus. So they found to be the nucleus irregular and of potato shape and dark as charcoal. Okay, so they illustrate the structure or the interior of the comets, and there was enveloped by a cloud of dust. Okay, for the Halley's nucleus, scattered light throughout the coma, and making spacecraft unable to discern much surface detail. So the spacecraft found jets of matter streaming from the nucleus, and that the gas and dust vented only from the sunlit side. Okay, so next one is the White 2, visited by NASA Stardust mission, named after the Swiss astronomers Paul Wirt, who discovered in 1978. And they found out the cometary particles were collected and returned to Earth using a form-like aerogel detector. Okay, and the evidence for the nitrogen-rich organic material were found along with the unexpected presence of silicate materials that should only have formed at high temperature. So that is the space mission to comets. Okay, so this is the cometary dust particles. Okay, so now is the Tempel one. Tempel one is named after the German astronomers who is discovered in 1867 and visited by 400 kg projectile. Okay, next one will be the Tempel one in 2005. So the name after the German astronomers who discovered in 1867. Okay, visited by 400 kilogram projectile at a speed of 10 kilometers per second. Okay, when NASA's Deep Impact watched it from 500 kilometers away. And they have done the spectroscopic analysis of the ejected gas from the collision, confirm the presence of water ice and many organic molecules. The observation of the crater suggests a low density internal composition. Okay, so we finish about the space mission. Okay, we have the last one should be the Churyumov Gerasimenko. Okay, so it's named after the two Soviet astronomers who discovered it in 1969. has orbital period of 6.45 years, visited by the Rosetta mission with its lander Philae being the first spacecraft to land on the comet nucleus. Okay, and the Philae detected a large amount of free molecular oxygen and found the deuterium hydrogen ratio of the ice on the comet is 3 times higher than on the Earth. So that is the space mission to comet. So we have basically how many mission? Okay, you can see from this slide. Okay, 32 slide 32 and until slide 37. Okay, so we stop here and we continue for part 2 of this chapter. Okay, thank you.